Shall we start again? So sometimes these regular expressions can become quite long and quite complex to understand. And then it's often useful to play around with them in a artificial environment. And really useful website is this regex101.com, where essentially you type in the regular expression on the top that you want to investigate, and then on the bottom you can type in some test strings that you would like to have matched. And so it highlights immediately which kind of words the regular expression matches. So here in this case I have hello, where the first L can be either little or large. But also here on the right hand side it explains to you what the regular expression does. So if you're unsure about what it means, you can kind of at least try and read through through this explanation. So this is kind of a tip to get started for complex regular expressions. And as with many things, it's advisable to start very simple with regular expressions and then slowly build up complexity. If you try to kind of capture an extremely complex string in one go, most likely it's going to fail, and it's going to be very difficult to figure out why it fails. So it's always good to start simple and then add complexity as you go along. So we were talking about these anchors where we could specify the beginning of words and the end of words, the beginning of a string and the end of the string. I just wanted to point you to some caveat, or to one caveat that you need to be aware of. So let's look at this simple example where we have where we want to match some, we have some text here over multiple lines. And then our regex is head, so the beginning of a string, \1, and then followed by 4 characters. Okay, and so our hope is that we want to match blue, apple, and pine. Yeah, and so it turns out that this is not what's going to happen. Instead, we only match blue. Okay, and so the reason for that is because by default, the regular expression engine in Python means that the head symbol in the Python regular expression engine means the beginning of the string, and not necessarily the beginning of a new line in the string. You see the difference? Okay, so this string here has only one beginning, namely this is a multi-line string, and the string starts here. But of course, there's multiple new lines inside that string, right? But by default, the head anchor only matches here. So if you're talking about multi-line strings and you want to match words that also start at new lines, then you need to add a flag. And most functions in the RE module have this flag option that you can add. And the flag that you in this case are interested in is the multi-line flag. So either re.multiline, but you can also just write re.m. It's the same thing. It's flags. Okay, and then you can see that the output now matches all the items that occur at the beginning of a line: blue, apple, and pine. So I think this is also relevant for your assignment. Also, I got the question over the break if this is relevant for your potential future job, and it absolutely is. Right? And I think actually, I hope at least all the lectures in this course are relevant for your future job. But regular expression is definitely something that you probably use at some point, especially if you go into data science. Because there's a lot of data cleaning necessary in data science. Okay, so now we move on to our next example, which is very similar to the first one, but it has some additional challenges that we need to solve. So this example is about validating IP addresses. So IP addresses, an IP address is again an address that identifies a device in a network, and it has a slightly different format. You can see some examples here. So I've used the doc. We can use the doc testing module, and I have three examples here. The first one is a correct one. The second one is too long. It's supposed to only have 4 numbers. And the last one is also correct. So let's implement the same. Let's try and implement a solution here. So we can use exactly the same strategy as we used last time. So I might as well copy it over. Let's go back. Let's take all of this and let's fix it. So what do we have? We have 4. We have 4 numbers that we want to match. Okay, so we're talking about a digit here. \d was a digit. Then our regular expression is separated by dots, in this case, not by colons. And because dot stands for any character, I need to escape it because I mean the literal dot. So I write \dot here. And then I want to have the digit character, but it's always 3 times. So I'm looking at this last address here. So the digit always occurs 3 times. And then in total, I want to have 4 of these guys. Right? 1, 2, 3, 4 of them. Okay, so I guess we can keep this. We add the end of the line and the beginning of the line here that we can keep. Then this is fine. So we apply the regular expression to all the IP addresses. We don't need the print statement. Then we check that the list is not empty, and then we return it. Looks good. Okay, let's see what we get. So the tests don't quite pass yet. We expect true, false, true, but we get false, false, true. Okay, so what does it mean? The last one was identified as a valid IP address, which is good. That's what we aimed for. The middle one is too long, and that is correctly identified as a non-IP address. And then the first one is correct, but it was not identified as a valid IP address. And the reason is that at the moment we're expecting always 3 digits in the IP address. But of course, it's perfectly fine to write 127.0.0.1 instead of having to write 0.00000000001. Right? So this is we don't want to force people to always write out this. So we need to refine our regular expressions. And what we need to do is we need to add something called quantifiers. And quantifiers allow variability on how often a character may occur in a string. Okay, so what I will do now is instead of saying I want to have 1 digit character, I can write \d plus. And what that means is that I want to have 1 or more digit character. Okay, so now I also don't need this times 3 anymore because the plus handles that for me. Okay, so now essentially all I'm asking is I'm matching 1 or more digit separated by dots 4 times. Okay, so if you test this, now all the tests pass. Okay, so there's more quantifiers. There's also a star quantifier, and the star represents 0 or more. So with a star, the digit actually becomes optional, and this would also become a valid IP address if you simply remove the digit. Okay. And then finally, there's, let's have one more example. Let's say I have 1127. So this is actually an invalid IP address because the number is too high. A number too high. So because the maximum is 255 that we can allow. So we need to be even more restrictive. We want to say we allow digits 1, 2, or 3 digits. Right? That's what we want to allow. And there's another quantifier for that, and that's specified with curly brackets. So if you add curly brackets here, you can say 1 if you want to have exactly 1, or 2 or 3. But you also can have 1, 3 if you want to specify digits 1, 2, or 3 digits. So let's see what happens now. So yeah, I of course need to update my expected test results. So the last one is a non-valid IP address. If I run this again, it passes. Does it make sense? Yeah. Okay, so just to give you an introduction, just to summarize these quantifiers. We have, so, and just to point out, so there's of course, there's a lot of notation and a lot of special characters that I'm introducing in this lecture, but you don't need to remember them, at least not all of them. The important thing is that you know about them and that you can look them up. That you know about them, you know that they can do certain things, and if you need them, then you just look it up. Right? So don't worry about the details, but you should at least get the idea. So we have the question mark for 0 or more, and often this question mark is also called the maybe operator, because essentially if you add the question mark, then you might have that character, but you might also not have that character, so maybe. Then star is 1 or more, plus 0 or more, plus was 1 and more, and then you have the curly brackets for specifying an exact amount. Okay, but now let's make things even more complicated. So now another case that we can come up with, right, is if we write 256.0.0.0.1. Okay, so now we have so this is an invalid IP address because the first number is higher than 255, so we can already write false here. But of course, our engine for our regular expression, this is perfectly valid because it contains of 3 digits. All of the items consist of 3 digits. So our tests will fail. So now we need to, in order to tackle, this can also be tackled with regular expressions, but we need to dive a little bit more into advanced regular expressions. So I need to introduce a concept called groups. Let's make this big for a second. So let's, okay, in order to motivate groups, let's first remind ourselves what these character classes were. So the character classes were with these square brackets here on the bottom. And it was essentially a set of characters that you would like to match. So square bracket ABC was you want to find either an A or a B or a C, right? And then, of course, you can use the quantifiers, question mark, star, plus, to repeat that. So if you have the first example here, square brackets ABC question mark would match either nothing, because it's a maybe operator, or A, or B, or C. Okay? So the second example would be square brackets ABC star. Then you match nothing, or A, or B, or C. Or you match AA, or AB, or AC, and so on. Right? But they're always considered as individual characters in here. Now groups are different because, so groups are, the notation is up here. You have the bracket, question mark, colon, and bracket closed. And then you have the string in here. And so a group is one unique object that you can't separate anymore. Okay, so if you write bracket, question mark, colon, ABC, question mark, then you match either nothing or ABC. Okay, and if you do with the same with the star, then you match nothing, ABC, or multiple of that. So ABC, ABC. Does it make sense? So this question mark colon is actually optional. It works just as fine if you don't add it. The reason why we have it here is because the normal brackets also has another meaning. So I will talk about, you can see here is groupings 1. There will be also groupings 2 and 3. That will talk more about advanced other features of the normal brackets. So if you're interested, but if you want to only use the feature that I explained just now, then it's advised to use the question mark colon syntax here. So you can even, this is also, this is even described in the, if you open up the regular expression helping page here, then you can see, where is it here? So the curly, the normal brackets with the question mark colon kind of is a specific version of the parentheses, and you can see there's many other ones. Okay, but where were we? Yeah. Okay, so that was that. So yes. So now what we can do, we can try and make our apply what we just learned to these IP addresses. And so what we now can do is we define yes. So, okay, if we want to apply this now for the IP addresses, what we can do is we can see that this dot, there's always this dot, right? So these groups, they're essentially a set of characters that are repeated, that occur multiple times. So then you can use the quantifier. And in our case, in the IP address, there's the dot, there's always a dot, and then some digits. And then there's another dot and some digits, another dot and some digits. So we will be able to write these 3 lines now much more compactly than what they're written at the moment. So how do I do that? So I write a new regex that replaces the one down there. So, okay, I start with first a digit that occurs between 1 and 3 times. That captures the first 3 digits. And now I define a group. So I use the bracket, question mark, colon. The group should always match, should define these types of characters here. So it's always first a dot. So remember that you need to use the backslash dot, because the dot stands for any character, so I need to escape it. A dot, and then I again have a digit 1 to 3 times. Right, so now I've described a cube that looks like this. So now I close the bracket. Now my cube has finished. And now I want to say that this cube occurs 1 to 3 times. Okay? Because I have this guy, then I have it again, dot, digit, 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 and then again. Okay? And I need to add the row, of course. So now I don't need this anymore. I've written this as one line, much more compactly. And then since we want to reduce it to one line, I can also merge that first beginning of line here, and also at the very end, I add the $sign. So now I can also get rid of this. Yeah?
The grouping, should it happen 1, 2, 3 times, or should it happen exactly 3 times?
Oh, that's a very good point. It should absolutely happen exactly 3 times. Thanks. Let's see if it works. It works, except that the last example doesn't work yet because we haven't fixed that one yet. Okay, so that's a bit more advanced, but I hope it still makes sense. Yeah. Okay, so now we still haven't fixed the first example, the last example. So let's go to groupings 2. Okay, so when you define these groups, you can also use introduce or statements or if statements. So if you want to match characters that consists either of the string AB or CD, you use the notation brackets, question mark, colon, AB, vertical line, CD. So by using these vertical lines, you can add if statements or ors into your groupings. Okay, and then of course the rest applies as before. You can add quantifiers. So the last example here, right, matches AB or CD, and then multiple of these. So let's see how we can use that. That knowledge to try and fix this last example here. So I again start from scratch because now it's becoming quite advanced. So I will start again. I will start with describing the numbers. So with that I mean valid. What are valid numbers that I can put in here? Okay, and so I will use a group to do that. So question mark, colon. Okay, so and now we have if statements, right? So this is what I need here. So either our number starts with a 2 and 5. So everything from 250 all to 250 to 255 is valid. So if it starts with 2, 5, then I can have anything between 0 and 5 here. Okay, so that captures that case. Now I have an or statement. Then I handle the cases, everything that is between 200 and 249. So I start with a 2, then I have a digit between 0 and 4, and then I have a digit between 0 and 9 here. So for this 0 and 9, I could have also used \d, but I just keep that here for consistency. Okay, so now we've handled all the 200 cases. So now we just need to handle all the other cases. So either we have a 0 or a 1. So this would be the 100s or the tens. Then we have 0 to 9. And then we have again 0 to 9. So that should just be like this. Then we close our group, and that's it. So the only thing that we haven't handled yet now is that for the tens, one might have, we might not write out the zeros at the beginning. So the way I fix that is that I add a question mark here and here. Okay, because these are optional. If I only want to write out a 1, then I don't need to write out the zeros. Okay, and so now I can write my regex. So I use the a formatted string here where I use these numbers. So essentially, I want to have the beginning of a line. Then I do a then I do a variable insertion. So this is now a bit. This is now a formatted raw string, and so now if I use the curly brackets here, I do and I want to have numbers here, of course. I insert the content of numbers here. So all the stuff here will be replaced by the content of numbers here. Okay, so this is the first number that I want to match, and now I have my now I define a group again that captures these guys here. So I have my group, question mark, colon, backslash dot, that's the dots. Then I have again these a number. Then I close my group. I'm done, and I know this should occur exactly 3 times. And so now comes something special here, because I use the formatted raw string. Python would think that it wants to do a variable substitution here, but I do mean a literal curly bracket. So in formatted raw strings, you need to use a double curly bracket. Okay, did you follow? So I could have also done, if you don't like this, I could have also done the old style Python. I don't know if this is much better, but I could have done this. Format numbers. It's the same substitution. But yeah, anyways. Okay, so then we don't need this anymore. And let's cross our fingers and see what happens. This should now match exactly what we want and nothing more. No. Oh, I'm missing an end of line. Woohoo! That was that was a wild. It was almost a wild shot. I have the solution next to me, so. But it was kind. I mean, of course, that's quite complex. Okay, are there any questions regarding this regular expression? No? That's a good sign. So now I think, oh, okay, so now comes one last thing. Again, it's regarding groupings. So the last thing that you can do, that is, I think, essential in regular expressions, are substitutions and back references. So so up to now, when we defined these groups, we always used this question mark colon. But the groups also have another feature if you don't use the question mark colon. So if you just use the curly brackets, then the regular expression engine actually remembers what was matched within these curly brackets, and you can reference back to that content again later on. So if you want, so typically a problem is if you want to match, are they called palindromes? Where you have the symmetric words. So if you want to write a regular expression that detects palindromes, you need to remember what was written at the beginning, right, and match it to what was written at the end. So what we can do here is a very simple version of that is that we have an A, so we match an A, and we remember that content. Then we expect a space, B space, and then we back reference to the content that was in the first bracket. In this case, it's just an A, right? So that means here we match A, B, A. But of course, we could also make this more interesting, right? And say we have a word character in here, right? And so in this case, we would also match E, B, E, for instance. And you can do this multiple times. So in the second example, we have A, B, C. So we have 3 groups. None of them have are groups that with back referencing. And so then you can use up to numbers \3, \2, and \1 to reference to these values. And so the numbering is that the first bracket has the reference \1, the second one has the reference \2, and the third one has the \3. Okay? And so just to highlight you again the difference between the question mark colon. So all the question mark colon does is that it does not create a back reference. So this is an unnumbered. This doesn't become a number assigned. So if you, in this example, if I were to remove the question mark colon, I would have to would need to change this from a 1 to 2, because the first one would be numbered. And so in regular expressions, you actually only have back references up to 9. So if you have a crazy regular expression, then you need to be, you're kind of restricted in how many back references you can make. There's one last, there's also \0 that you can use. And that actually matches the entire, that always matches the entire string. So it can, for instance, be useful sometimes in the editor if you want to do a replacement. So let's say I want to replace groups with, and so now what I want to replace it with is \0. So now \0 matches the entire string. So in this case, it matches groups. And then I can add something, for instance, right? If I'm lazy. So the equivalent thing would have been here to make groups a back referenced group, and then I had to, and then I could use \1. Okay, so let's see. So what this means is, yeah. Yes. So I think I'll stop here with the groups. Any questions regarding groupings? No? Okay, so then let's go back to this first example. And I want to show you again what I did at the beginning. And now you should understand what's going on, except my Vim commands, which are special. But you should understand the regular expression. So I type down here. So my task is, right, that I want to replace again the indices or in the square brackets. So colon $s \v is my Vim stuff. So that doesn't, don't need to care about it. But now comes the exciting part. So I want to match first the curly bracket. So I use a the square bracket. So the square bracket has a special meaning in regular expression, but I mean it literally here. So I use \square bracket to match it. then I have some characters. So that I want to group because I want to swap them later on, and they can be. I guess they can only be. No, there's a minus and plus here, so they can be. I just use a dot here to represent any character, and there can be multiple of them. Okay. So at the moment I match it all the way to the end, but now I also require that there's going to be a comma in a space in my string. And then I match the second part of that string. So there's again, I add a group because I want to match it later on. And at the end, I have a closed square bracket. Okay, so now you can see all the indices that I'm interested in are now being matched by my regular expressions. And I define two groups with the content that I want to replace. So now this is again Vim, my neo Vim that does this. So now this text is removed, and now I can type in what I want to have replaced it with. So I want to have a square bracket. In the replacement, I could add a backslash to escape it, but it's actually not necessary here. So I want to have a square bracket, and now I use the group, and now because I want to swap it, I use the back reference for the second back reference first, and then comma space again, and then the first back reference second, and then a closed square bracket. Okay? So now I press returned, and now this file was only 20 lines long, but the amount is constant. The amount of work is constant for me. So if this file was 1,000 line long, it wouldn't have taken me longer. So just to see again, so we did indeed replace the position of the indices. Okay, so one last example, a more real-life example. So Google has some exercises, Python exercises that one can do, and one of them contains baby names. And let's take some more modern ones. Let's take the 2008 ones. So this is a HTML file, essentially with all the baby names that and how popular they were. Let's check if Simon is 261, so that's not so popular. Okay, but so as you can see, this is HTML, and a very common task, especially if you're working in data science area, is you're faced with files like this, and your task is to do some analysis on it, right? Some statistics or whatever, machine learning. So of course, you don't want to work with this file directly, but you want to extract the relevant information out of that file. Okay. And this is a task that can be done very, very quickly with our editor alone. So we don't need to write a program. If we know regular expressions and we have a good enough editor, then this is now a task of less than 5 minutes. So what do? The first thing I do is I remove all the rubbish at the beginning and the end. Right, so I restrict it to kind of the interesting content. Okay, so now I have these 1,000 baby names here, but still with a lot of text in between. So now we can use our regular expression knowledge. So I start again my regular expression engine here in Vim, $S/\v. So now we've got it started. And now let's go. So the first thing that I want to match is the digit here, because that's the rank that I'm interested in. So, and I'm going to group that because I want to reference it back later on. So I want to have some digits that I want to match. So I use the \d plus, and then the brackets to group it. Fantastic, there we have it. And then there is some text in between, and then comes the name. But as you can see, the text is always the same length. So one way to do this now is to just specify I have a dot, so any character, and in this case it's, let's see, it's exactly 9 characters that I want to match next. Okay, so I group that. I don't group that because I don't want to reference to it later on again. But now comes the name. So the name is a set of word characters that I want to group again. So I use \v plus. I close the group. So now we have the name. Now comes again some rubbish that I don't want to keep. So 9 characters that I'm not interested in. And then there's another. Now it's the girls' names. So there's some word characters again that I want to group because I want to keep them. Okay. So now I've identified, I grouped the important text that I want to keep. Now, because I want to do replacement, so if I just did this now and started replacing, I would still have all this remaining rubbish. So what I'm going to do is I'm going to match the rest as well. So the way I do that is I just have some dot star to just match everything at the beginning. And then also dot star at the beginning here. So except that, oh nein, I missed it. Oh, okay. Bear with me. Okay, let's try this again. \d. So first comes some not digits. Now you can follow me again. Then we have some digits plus. Then we have 9 characters. Then we have some word characters that we want to capture. Then we have 9 non-word characters. Then we have some word characters that we want to capture. \v. And then we have some other stuff that we don't want to capture. Okay. Now it's okay. There's some more work to do, but let's forget about that for a second. But now we have hopefully the information that we want to capture. So now I can use the back reference. So \1 was the where was the ranking. \2 was the man's names, and \3 were the female names. Okay, and I press return, and I've tidied up my file. So if you want, I mean, as the last step, you can replace these guys here with nothing. So let's see. Oh, okay. No, okay, I'm not going to do this now. But you can see where I'm coming from. So yeah, I hope that was helpful. I hope it's going to be helpful for your assignment. Are there any questions? No? Okay, then see you next week. Hello.
Hei, hva var de greiene du hadde i den Python-fila? Du hadde noe som så litt ut som Python på en måte, men i den der stencil core strings og sånt, det var ikke relatert til det du sa egentlig. Jeg bare...
Nei, skal vi se. Det var bare demokod også, men sånn ja. Ja. Det faktisk Python 3. det er Python 3 spesifikk.
Ok.
Så er det nytt feature, hvor du kan skrive inn, det er type hints, heter det.
Ja.
Så du kan skrive inn hva slags type den funksjonen skal ta inn.
Ok.
Men den er faktisk helt ubrukt. Du kan skrive inn hva du vil ha. Det spiller Python bruker den faktisk ikke.
Hvorfor
Men
det da?
det er egentlig bare for dokumentasjon. At folk vet hvordan de skal bruke denne funksjonen. At de, så det er mest den Python 2 hadde det ikke. Og så hovedmotivasjonen hvorfor de Python 3 hadde nå, er fordi hvis du har veldig store prosjekter, da er det ganske nyttig at du kan dokumentere de typen. Også, det er jo ikke streng. Det er jo Python-interpreter bruker det jo ikke, men også bare for dokumentasjon.
Ja. Men hvorfor er det fordelaktig for dem for å legge til en docstring? Altså normalt så har vi en docstring her oppe, så
ikke sant?
Navn, også type, og så forklaring på hva det er.
Det er en veldig god spørsmål. Ja. Men den docstringen, det er jo ikke, så på en måte er den den offisielle metoden for å dokumentere typer. Den docstring, der finnes ikke en guideline hvordan du skal gjøre det. Også Python har det nå gjort offisielt på en måte.
Ja.
Men det er den eneste forskjell.
Vil du anbefale å bruke dette?
Jeg bruker den egentlig ikke.
Nei.
Men det er også fordi du vet jo ikke alltid, når du vet at I er faktisk en int, som den er jo en veldig enkelt eksempel, så da synes jeg det er en god idé.
Ja.
Men det er også ganske ofte at du skriver en funksjon som kan fungere begge med en list, og så en numpy array, og så med noe annet. Og så da synes jeg det er egentlig ikke så en god idé å spesifisere at du kan bare bruke den funksjonen med den typen.
Ja, for du har ikke muligheten til å spesifisere flere typer her, bare
Nei, jeg vet ikke at jeg vet om det, men det er kanskje verdt å sjekke.
Ja. Nei, men det så litt interessant ut.
Ja, men det er et godt poeng. Ja.
Men det hørtes litt ubrukelig ut på en måte, men...
Nei, jeg tror for store prosjekter er det ganske nyttig også. Altså, hvis du vet at denne funksjonen er hovedsakelig brukt med disse typene. Og så, det er kanskje editorene som bruker det, jeg vet, fordi det er så nytt, så jeg vet ikke om det, men det er kanskje editorene som sjekker at denne funksjonen er brukt riktig, på en riktig måte.
Okay. Ja.
Men i hvert fall på C, eller C++, har du det jo. Fordi da er det veldig strikt typing, og så da kan du ha masse sjekking. Er det før du kompilerer programmet.
Ja. Yes, nei, men takk for det.
Ja.
Hei.
Hallo.
Når jeg skal skrive, når jeg har regex uttrykket mitt, og jeg har så skjønner ikke den altså det her fargetingen min, når jeg legger farge på det, så skriver det ut som alle fargene er oransje. Men da kommer det 2, 3, og så kommer plusset med rødt for eksempel.
Kan vi bare prøve hva du mener? Så du snakker om 2 + 3?
Ja. Når jeg da, for jeg har bare sagt at tallene skal være en farge, og så pluss skal være en annen farge.
Hva mener du med? Ja, sånn ja. Ja.
Men da skrives det under hverandre. Så den tar på en måte hver del.
Ja, når du printer den ut, skal vi se.
Ja, det skrives under hverandre.
Ja, så det finnes en...
Skal jeg lage det sånn som du lager et uttrykk for at jeg sier det kommer tall, det kan også komme et plusstegn. Og da tar du ikke plusset en annen farge.
Ikke helt sikker hva du mener. Men kan det være at du mener, så problemet er kanskje hvis du har, skal vi se, print row, mener du noe sånn at du vil ha den i en linje?
Ja, for det blir sånn der. Sånn at jeg får tallene under, etter hverandre, og så kan plusset nederst.
Ja. Men print har en endline... skal vi se... Så jeg tror vi skulle gjøre det sånn. Fordi by default, hvis du bruker print en string, da printer den en string, og så til slutt en ny line. Men du kan overskrive det med den argumenten her. Og så da printer det bare en string uten en ny line. Og så resultaten er at den printer A, og så på samme linje som B. Kanskje det hjelper?
Kanskje det den gjør nå, at den går gjennom linje fra den tekstfilen, eller den filen som er sendt inn, og så ser den at, ja, men ok, da ser vi om den setningen her, eller den her, går igjen i regelsystemet, syntax, og så, altså den find all.
Ja.
Og så setter farge på dem, sånn at de blir like. Men da skrives de litt under sånn. Mens det jeg vil at den skal gjøre, er å skrive sånn at det matematiske uttrykket for eksempel får tre tall av oransje, og så et plusstall som er rødt, og så et neste tall er oransje, i stedet for å få alle tallene samlet, og så pluss og minus og delavganger og sånne ting.
Ja.
Er ikke det mulig?
Så hva jeg anbefaler er å bruke det, og hvis det ikke fungerer, skriv en veldig enkelt eksempel, og så poste den på Bjørn.
Ja, da prøver jeg det.
Ja.
Takk skal du ha.
Ja, jeg lurer på hvorfor du ikke har lært en regex på videregående skole og ungdomsskolen. Dette kunne jo redda meg på, eller spare meg masse tid, liksom.
Ja.
Når jeg skal lete etter svar til oppgaver jeg absolutt ikke bryr meg om og bare må gjennom fordi skolen vil at jeg skal kunne nynorsk. Kunne jeg brukt regex i å finne masse ting på mye kortere tid.
Ja. Det må du ikke spørre meg.
Hvorfor er det når jeg er 21 år, så får jeg vite om noe som jeg skulle trengt når jeg er 16?
Ja. Nei, men det er jo...
Du har egentlig en klage, da.
Nei, men det er jo...
I alle skjønner ikke på det. Der er jo... Nei, jeg visste ikke det.
Men jeg er glad å høre at stedet. Men nå vet du det jo. Du har fortsatt mange år hvor du kan bruke den.
det.